All right, let's try some more here. Solve and check algebraically. Whenever you have a single square root, you're going to need to square it. Unfortunately, we can't square everything like this. We actually need to square the entire side. And if you square the entire side, you can't just bring this in. You're actually going to have to what we call FOIL. And so the hint for this is to get the square root alone. So we want to get the square root alone. So we're going to minus this 5 over here. So this happens when you see, and anytime you see just one square root symbol. We'll get that alone first. So square root of x plus 1 is equal to x minus 5. Now I can't put those together because they're not like terms, so we just leave them separated, x minus 5. Now I can square it, and I can square it. And that cancels out, leaving me with an x plus 1. However, the x minus 5, when you square something, means that you have to multiply it by itself. So x minus 5 squared means x minus 5 times x minus 5. And for that, you're going to need to FOIL. We need to expand this in. So x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is also a negative 5x. And negative 5 times negative 5 is a positive 25. And I see that these are alike, negative 5x and negative 5x. So I can put those together. Negative 5 and negative 5 will add to get me negative 10x. And like I said last time, if ever you get a square root, an x squared function, chances are you're going to need to bring everything over to one side. So we're going to minus the x and minus the 1, minus the x and minus the 1. Those are gone, making it a 0. So we have an x squared, and then we have a negative 10x minus x, which is a negative 11x, and 25 minus 1, which is 24. And now we're going to need to factor this. So, or see if it's even factorable. I need to get to 24. So 12 and 2 could work, 6 times 4. But looking at this, I need to get 11, and I know that 8 and 3 will work. 8 times 3 is indeed 24. But my diagonals would be 3x and 8x, both positive, which would 3 plus 8 would give me 11x. And that's close, but I've got a negative 11. So in order to get negative 11, both of these would have to be negative. So what I need to do is I need to make them both negative. So the left side still multiplies to x squared, and the right side still multiplies to positive 24. So 0 equals x minus 8 and x minus 3. And now we'll need to actually solve those, where I've instantly run out of room. So let's just bring this up here a little bit. So I can have x minus 8 equal to 0. So this one can equal 0, or this one can equal 0. So I will have to plus 8 onto this side, meaning 0 minus 8 is minus 8. And then I can add 3 to this side. 0 plus 3 is 3. So it looks like negative 8 and 3 are our answers. Hopefully these both work, but we do have to do a check. So I'll do a check here, and then I will erase it because I'm running out of room. So I'll check this. So where's our equation here? There it is. So the square root of x plus 1. Oh, I actually have two checks. So I'll write them down. X equals negative 8. We're going to have to check that one. And x equals 3. So we're going to have the square root of x plus 1, or negative 8 plus 1. And then with a plus 5, and it must equal x, which in this case is negative 8. So negative 8 plus 1 is going to be negative 7, plus 5 equals negative 8. And there's no square root there. Okay, I'm looking at this right now, and I'm thinking this does not look at all right. And hopefully you spotted this. You're like, Mr. Bowler, why on earth would you do this? Why would you plus 8 and then minus 8? Well, I have no idea why I did that. Whatever you do to one side, you must do to the other. So you cancel out the 8 by adding it. You got to add it to this side. which gives you a positive 8. So I need to check that, positive 8. Which makes this inside going to be 8. Instead of x plus 1, it'll be 8 plus 1, which is 9, and the square root of 9 is 3. 3 plus 5 is equal to 8. And on the other side, we were equaling x, and our x value is 8. So that's 8, that's 8, that's 8. And 8 does indeed match. So looks like that one's okay. In this one, I did add 3 correctly to both sides. So x plus 1, in this case, is 3 plus 1. Equal or plus 5 is equal to x, and in this case x is 3. So 3 plus 1 is 4, so I've got the square root of 4, plus 5 is equal to 3. The square root of 4 is 2. 2 plus 5 is equal to 3. 2 plus 5 is 7. 7 equals 3. Well, nope, 7 does not equal 3. So that one we need to reject. So this one gets rejected, leaving our only answer to be positive 8 and not the negative 8 that I had written previously. So I'll just zoom that out for a sec in case you want to pause it. And now I need to erase it because I run out of room. All right. So I'll try not to make a mistake this time, but no promises. The square root alone is what the hint was. And so we're going to need to move over this 2x. It's a positive 2x, so we'll subtract it to this side. So I'll have the square root of x plus 4 is equal to 2 minus 2x. I can't combine these to get 4 or 0 because they're not like terms. So now I can square both sides. Square cancels with the square root, leaving me with just an x plus 4. And on this one, I've got a 2 minus 2x squared, which means I have to multiply it by itself. Now I need to FOIL this, so I'm going to FOIL this all out. I'm going to expand it out. So I got x plus 4 equals 2 times 2 is 4. 2 times negative 2 is negative 4x. 2x times 2 is also a negative 4x. And negative 2 times negative 2 is a positive 4, and x will give me an x squared. Well, I don't like the way that's written. It's not in descending order, so I'm going to put the 4x squared first. Negative 4x and negative 4x are like terms, so we can get a negative 8x. And there's a positive 4 here, so I'll put a positive 4 here. And notice that this is an x squared equation, so chances are we need to bring everything to one side. So we'll move over the x and move over the 4. Move over the x and move over the 4, and we're going to subtract both of them. So we've got 0 is equal to 4x squared minus, minus 8 minus 1 is going to be a minus 9, and 4 minus 4 is actually going to be 0. So when it comes to something like this, it's not going to work to factor it like that. However, what we can do is we can take out an x. Oh, if you heard that, that's just a kid screaming in the background. I will just pause this. Okay, so take out an x out of both of these. If you take an x out of the first one, you're left with the 4x. If you take an x out of the second one, you're left with just a negative 9. And so now we can split these up. So you can have x equals 0, or you can have 4x minus 9 equals 0. And this one's already done for you, which is kind of nice. This one, however, needs to have the 9 moved over. I'll do that up here. So 4x minus 9 equals 0. So you're going to add the 9 over to there. So 4x equals 9. And then we can divide by 4. So x equals 9 over 4. Or 4 can fit into there twice, leaving 1. Leaving 1 out of 4, we'll leave a 1/4, so 2.25. So 9 over 4 or 2.25. Now, we need to check both of these, unfortunately. So let's take a look here. We're going to check. Because chances are one of them won't work. Let's do 0 first. So put in 0 into the original equation. So the square root of x plus 4, in this case 0 plus 4, plus 2 times x, or 2 times 0, equals 2. So 0 plus 4 is 4, so 4 square root of 4, and 2 times 0 is 0. The square root of 4 is 2, 2 plus 0 is still 2, and we have the 2 there. So yes, it looks like it matches. And now we have x equals 9 over 4. Okay, so we get the square root of 9 over 4 plus 4, so x plus 4, and that's our x. This is over 1, so we'll need to get a common denominator. Plus 2 times 9 over 4 is equal to 2. Well, is this going to work? Let's see. So I need to put a common denominator, times this by 4 and times that by 4, so I get 8. So I have the square root of 9 over 4 plus 8 over 4. And then here, this is a 2 over 1, so you can multiply the tops. 2 times 9 is 18, 1 times 4 is 4, equals 2. And 9 plus the 8 is going to be, 4 times 4 is not 8, it's 16. So 9 plus 16 is 25 over common denominator 4. And I can actually reduce this. This is going to be 9 over 2 is equal to 2. And this is that one that we learned about this before. You can split these up into two separate radicals. So square root of 25 and the square root of 4. So that leaves me 5 over 2 plus 9 over 2 is equal to 2. And these already have common denominators. So 9 plus 5 is 14 all over 2. And 14 over 2 is 7. Wow, that just boils down to 7. Which is not even right. So how does that work? And it's not even right. So let's recap that here. So I had 9, I had to put this in. I had to put 9 over 4 in, plus 4. 2 times 9 over 4 is equal to 2. And I needed a common denominator to add fractions. 4 times 4 is not 8, it's 16. And when I added those, 9 plus 16, I get 25, which I can split up into two separate ones, 25 and 4. Square root of 25 is 5. Square root of 4 is 2. So I have 5 over 2. And this thing here multiplied to 18 over 4, which can reduce to 9 over 2. So later on, when I added 5 plus 9, I got 14 all over 2, which ended up getting me 7, which wasn't even right. So I need to take this, and I need to reject it.